Okay, so on one of my recent videos, the relaunch of the live streams video, one of the commenters, I'm not sure it's okay to say their username, but on one of the commenters had asked me to go over some questions from the 2019 10A. Somewhere on my channel, I have a request form, but I haven't had a chance to get to those in so long that it's probably better just to make new comments if you wanted a certain problem done. So I asked them of the ones they picked, what one was the most important, and they said this 2019 10A problem 13. And we're going to go through that right now. So I'm going to make this a little bit smaller. Let triangle ABC be an isosceles triangle with BC equal to AC. The first thing is, do not read everything. Read until you can interpret. We have enough to interpret right now. So we will draw a random isosceles triangle. Maybe it's approximately what they claimed, and it looks like this. The letter that you see here and here, the common letter, is the one that goes in between the two equal sides. So then we're going to say over here we have A, B, and C. Now it says that angle ACB is 40 degrees, so you can label that 40. Further, it says construct the circle with diameter BC. By the way, as I'm reading that, my brain already launched to the next step of this 40, which is that this will be 70 and 70 by virtue of it being isosceles. That's called the isosceles triangle theorem. You should probably add it to your small notebook. If you don't have a small notebook, you can find the one I recommend on my website, which will be linked in the description below. It's a notebook made by Moleskine. There's a link to it on the resources page. So I would highly recommend you add that. Next thing up, though, let's draw this circle approximately. And it looks like it might, that's a pretty good circle, actually. I'm not too terribly disappointed in myself. One of the better ones I've drawn freehand with this pen on this device. So let D and E be the other intersection points. So this will be D right here, and this will be E right here. Then it says of the side with sides AC and AB, respectively. Let F be the intersection of the diagonals. Now, right now, I kind of don't want to draw this. You see, I'm seeing something else right now, and the moment that I observe something, I try to capitalize on it. That is this angle. This is a situation that we can look at as follows. Any circle, when you have this angle, and we know that whatever this is X, and this is A, and this is B, that is the arcs are A and B, then X will equal A minus B over 2. We'll go over where this is taught in a minute. It's taught usually in your geometry classes. You've got it seen right here. It's chapter 10 at the top of my screen from the volume 1 textbook, but it will also be, that's from AOPS volume 1. By the way, I have a class for that textbook that I use as the textbook I teach from called AMC Fundamentals. It's on Saturdays and it's discounted right now. Reach out to me through my website if you'd like to join. We went over just this concept a few weeks ago. So anyhow, continuing on from this point, what does that mean? Well, this angle here is 70 and that arc is 180. So 70 has to equal 180 minus arc DE over 2. Multiplying by 2 gives 140. That means arc DE right here must be 40 degrees. That's the arc measure, not the angle. Okay, so now let's go back, make the font smaller, and draw what they're talking about. What is the degree measure of BFC? And F is the intersection of the diagonals. I'm going to use the straight line feature. I'm going to draw from D to B. I'm going to draw from C to E. Keep in mind, another concept that we haven't yet used is that quadrilateral BEDC, and DE is not even drawn. I haven't drawn it. The arc is drawn, but not the segment. And I'm not going to draw it yet. But keep in mind, it is a cyclic quadrilateral, which opens the doors to cyclic properties should we need them. Now, in this problem, I don't think we're going to need them, but you should always be aware of the new developments on your game board or your problem solve as you're going. So from here, now what? This is F. It wants this angle right here. We have another situation very similar to this one right here. Both of these were small notebook concepts, by the way. When you have two chords crossing in a circle and you have this angle right here, and that is A degrees and that is B, then x will equal the sum of those intercepted arcs and over 2. So we're basically done. You've got 180, you've got 40. Add them to get 220 and divide by 2, and your answer is going to be 110. If you enjoyed this problem, give it a like down below. Check out the other ones. You can always make more requests, and when I have time, I will try to film. If you're interested in the class, you're welcome to sit in on one class for free. And there's no expectation of payment for that one class. Other than that, you can reach me through my website or the email on my channel email. Hope you're doing well and preparing well for this year's AMC. We're about 5 months now and the tests are going to be all over. Hopefully you started your prep. Oh, briefly, let's go look at one other thing. Here's chapter 10 where it's covered. These two concepts, by the way. At the beginning of chapter 10, you can see this concept here. And again, it shows that the angle right here is that arc minus this arc over 2. Here's the other one that we just used, the sum of these two over 2. In this chapter 10, you will also prove these concepts, or they will, and one or the other. You will prove them, they will prove them. The proofs are done in here so you can understand why these things are true. All of these are small notebook concepts. There's also a video on my channel that explains how to utilize the small notebook. It's called The Small Notebook Justified and Explained. I'll try to link it in the description. Again, hope you're doing well and preparing well, and I'll see you in the next video.